Okay, so this is quite a challenging example using the quadratic formula, but it is a pretty common application of the quadratic formula, so I wanted to make sure that we covered this. So imagine you have a shot putter, so basically it's this person who's going to throw something. And if you remember, I've talked about this, well, I've just talked about the shape of the quadratic graph. It makes a U shape. So a very common application is someone throwing something, because when you throw something, right, it's going to rise up and fall down, and it makes that same shape that a quadratic graph would make. So this is a very common application. In this question, they give us the equation of the shape that the shot put takes when it is thrown. And it says that the height is given as h, so that's kind of what this represents here. And then time is represented by t. So if you notice, we have the variables t and h in our equation. So kind of just imagine that you have this as your axes, and h is like the y-axis, t is like the x-axis. So normally you would see y equals 2 plus 6x minus 5x squared. However, here we've replaced y with h, and we've replaced x with t. So imagine t is like the x-axis, t is like the x variable, and h is like the y variable. So anytime they ask us to find h or t, they're just asking us to find the value of x or y. If you wanted to, you could rewrite this as y equals 2 plus 6x minus 5x squared, so that you're a little bit more comfortable with it. It's up to you. Okay, so what they're doing here is just asking us to solve that equation. So all you need to do is use the quadratic formula. Keep in mind that our a, b, and c values are swapped around here. Okay, it just goes from c to b to a. So we'll use the quadratic formula. X equals negative b, so minus 6 plus or minus the square root of b squared, 6 squared, minus 4 times, well, c is 2, that's fine, and a is minus 5. The order doesn't matter, sorry about that. And then all divided by 2 times a, which is minus 5. Okay, so we're solving here. Remember, we always start underneath the square root. So I'm going to come to the side. I'll have the square root of 36, which is 6 squared, and then plus 8 times 5 is 40. And so I would have plus the square root of 76. So bringing this down, x equals minus 6 plus or minus, replacing the square root as 76 divided by minus 10. All right, let's put that in the calculator and see what we come up with. Okay. So I have, I'm going to use brackets, minus 6 plus first, the square root of 76 divided by minus 10 gives us negative 0.272. And then we also have, just going here, I'll change that to a plus. What did I do minus first? Is that something different? Oh, it simplified it. Okay. Whoa. That's interesting. Okay, yeah, it simplified it for me. Oh well. So now I have the minus, sorry. Okay, so minus 6 minus the square root of 76 divided by minus 10 gives us 1.472. So let's think about what we just solved for there. We just solved for the time, right, of this situation, the time of what it took for him to throw this shot put. I know we came up with 2 different answers, but imagine that he threw it from this height, and this is like our starting value. If we extend our graph back, this piece of the graph is non-existent in real life, correct? Because he started right here, he threw that shot put, and then we're looking for the value, the location of where that shot put hit the ground. That's what we just solved for. We solved for the time value of when that shot put is on the ground at the height of 0, basically. for solving for the x-intercept. So this x-intercept does not exist in real life. That negative value, obviously, if we're looking at time, if we're thinking about this time representing real life situation, we cannot have negative time. That second x-intercept of the graph does not exist in real life. This is the only x-intercept that does exist in real life. So we only have one answer here. And that represents the seconds, basically, that it takes for that shot put to hit the ground. That's what we're representing there. That's what we just solved for. In this situation, hopefully you realize we found the time that it takes for the shot put to rise and then fall. Okay. That's what the second question is actually asking us. It says the shot hits the ground after t seconds. Write down the value of t. That's what we just solved for, because remember, our person is basically standing here. It's a great person. He threw the shot put. Imagine you extended the graph back. We just found two x-intercepts of the graph. This one does not exist. This one does. We just found the value of t, where the height is 0. If this is the height, right, that's like the y-axis. Where it's 0 is where the shot put will hit the ground. So the answer is 1.472 seconds.